Hello students, welcome back to AriserTalent. I am your maths teacher Arpita Sharma and we are studying the very first chapter of your 9th class and that is number system. Okay, so this is our chapter that we are reading, number system, correct? Okay, now we were talking about rational numbers in our previous lecture and in this particular lecture we will talk about irrational number. Till now we have covered the number system, the various categories of numbers, number sets, okay, and we have done some questions that have been asked in competitive exam in our previous class, okay. So, here it is irrational number and I have told you that irrational numbers are the numbers which are not rational and we can say that we cannot write it in the format P by Q. Now, just to identify this particular irrational number, you have to go through the rational numbers in a very particular manner first. Then you will know that which particular numbers are not rational and that will lie in that particular category. Okay, so this is clear to you guys. Okay. Okay, now if you are having this draw root 2 on number line type question, how will you do that particular question? Because you are having this number line, right, and let us suppose this is the middle of this and that will be 0 for sure. Here -1, -2, -3, -4 for now. Okay, now it will be 1, 2, 3, 4 and 5 and so on. Right. So, now I have to plot this root 2 value. Value, you know, all know that this is the value like something like 1 point something, 1.14 and something, but what is the exact value you do not know, I do not know. Okay. So, if I have to plot something here like in points, how will you calculate the exact point or will be mark the exact point out here to draw the value of root 2. How will you do that? So, here we are having you know about triangles, right, and when I say triangle, to be very particular, you all know about right angle triangle. Here we are having base, hypotenuse and base. No, base is covered, perpendicular, okay. So, base, perpendicular and hypotenuse in a right angle triangle, okay. So, in that we are having a relationship between these three and that is hypotenuse will be equals to the square root of perpendicular square and base square summation. That is the formula, okay. So, when you are saying root 2, if hypotenuse is root 2, perpendicular will be 1 and base equals to 1. So, 1 square plus 1 square I can say will be equals to root 2 and if 1 is perpendicular, 1 is base, then hypotenuse will be root 2. I am going to use that concept and whatever I am telling you is if you are having this right angle, this is of unit length, this is of unit length. So, base is 1, perpendicular is 1 for sure, then this has to be root 2. So, you can just draw a hypotenuse having this perpendicular and base equals to 1 unit, then you will be finding your hypotenuse as root 2 unit. So, you can measure this root 2 unit and have an arc of that on your number line. Is that so simple? Okay. So, we are having this 1 here, right, from 0 I am starting. So, you are having this 1 here, okay. Now, you are having this 1 here and you may have this 1 here, 1 unit, right, okay. So now you will be having this. This is what is your hypotenuse. So that will be root 2. Or else you can say, if I will draw, let us have some point. This is the point, let us say A, and this is the point, let us say B. Okay. Now this is a point C, such that CB equals to AB. Now if CB equals to AB, that means this portion is equals to this portion. What does that mean? That means that these two are of unit length. This is 1, 0 minus 1 is, sorry, 1 minus 0 is basically 1. So this is 1 unit, and I have created this as 1. So if this is 1 and this is 1, and I have drawn a perpendicular here, CB perpendicular to AB, or you can write vice versa, like AB is perpendicular to CB. Both ways, this is 1, this is 1, so this is what? Two sides perpendicular to each other. Now if I draw this line AC, for sure that will be root 2, isn't it? This implies that this AC will be equals to perpendicular square plus base square. Now both perpendicular and base is what? Perpendicular is this BC square, and this base is what? This base is what? AB square. Both are unit 1. So 1 square plus 1 square equals to root 2. So it's very obvious that this particular thing is root 2 unit. Now I don't need that thing here to be here. I need that root 2 measurement to be here. So what will I do? What will I do? I will use this length. You can use divider, okay, or else you can need a protractor. By this help, you will be having two sides of that. Okay, so you will having two sides of divider. Put one here and one here, right? After putting it here, with the same arc, cut this line with the same arc. Okay, so that will be something like here. The arc will come something like here. Now this particular point is root 2. Isn't it? This particular length will be equals to this length, because this is the, if you will draw the complete radius here, complete circle here, okay, then you will find out this is radius also, this is radius also, so the radius will be same, okay. So by this method you will get to point out the value of root 2 on the number line. This is about root 2. So this is the method how will you represent root 2 on number line. We haven't bifurcated that root 2 is which kind of particular, what you say, number. Is it rational or irrational? I haven't told you yet, but this is something you can represent it on line. Okay, so there are numbers, so you can just tell it where it is on the number line. So basically it is a real number, but which kind of real number yet to be find out. So note this completely so that we can move forward. Okay. Now after this we will be having one more thing to plot on number line. Okay. So the next question will be, here it is, draw root 3 on number line. So root 2 was fine, we have to make that perpendicular and that's done. Now what about root 3? We are going to use this root 2 in order to draw root 3 on number line. Okay. How? Let us find out. So this is basically what we are having as a number line. Okay. So that was our 0, that was our -1 and that was our -2. Okay, fine. Here it is 1 and it was 2 and so on, something like that. So this is 0, -1, -2, 1, 2 and so on, because this is a number line, that will be, because we are taking this length because we have to construct something here, right. So how you draw the root 2? For root 2, what you did? What you have done? Just construct a perpendicular, that was your A, B and C, and this was your root 2. You have constructed that. This is 1 unit, this is 1 unit. Here you were saying that CB equals to AB and also CB was perpendicular to AB and AC equals to root 2. Now, if I talk about root 3, so root 3, I can say that root 3 equals to 2 plus 1. Root 3 equals to root of 2 plus 1. Now, that can be further regarded as root 2 whole square plus 1 whole square. That means I am needing a right angle triangle with the base root 2 or perpendicular root 2 and 1 as perpendicular or base. Either way, if root 2 is base, then 1 have to be perpendicular, and if 1 is base, then root 2 is to be base. Okay. So now in that case, I am having root 2 here, I am having some 1 here. So how will I use that? I am having root 2. Okay. I am having root 2 and I need a line right from there, this center, okay, to go there and to become root 3. So that should be the hypotenuse, because this is the hypotenuse formula. That should be the hypotenuse. That means that will be the base, and here something here, that will be my perpendicular. So what I am doing, I am drawing a perpendicular to AC. Now perpendicular to AC will be something like that. This should be again 1, okay, and then I will join. Let us suppose this point is D, or okay. So this is C, this is B, this is A. Okay. Now I am just joining this D to A. What I have done, I have drawn AC perpendicular to DC such that DC equals to AB equals to CB equals to 1 unit. Okay. So this DC is first perpendicular to AC, and second, this is of unit work, just as in case of BC and in case of AB. Now what I am going to do? In triangle ADC, this was something which is rough work, okay. I was just giving you an idea of that thing, just do not mention it, okay. What you need to mention in triangle ADC, this particular triangle ADC, AC equals to root 2 equals to base, right. Then AC, okay, it is your base, then DC equals to 1 equals to your perpendicular, then DA is equals to hypotenuse, and that will be root of perpendicular plus base square of all these two, that will be hypotenuse equals to P, perpendicular is 1, so 1 square plus root 2 square, and that is gonna be hypotenuse equals to 1 plus 2, that is equals to root 3. So again that will be root 3. Now how will you draw this thing? You will measure this, okay, and just take that arc DA, this length DA, and will cut an arc of that length here, okay. So now root 4 has its value 2, root 1 has its value 1. So root 3 will be having some value more than 1 and less than 2, and there it will belong. When you will be talking about this, the value will lie here. So this is the value of root 2 here, root 3 here, root 1 here, and root 4 here. Fine. So basically we are here, we can here know how to draw, how to plot, or how to mark points like root 3 and root 2 on our number line, okay, because we have seen things like marking 0, 1, 0.5 on our number line, but we have not seen that. So we just covered it also, okay. So note this, noted. Right. Then find the decimal expansion of 10 by 3, 7 by 8 and 1 by 7. Okay, let us do it one by one. First we are having 10 by 3, second we are having 7 by 8, and the third we are having 1 by 7, isn't it? Okay, so let us starting the work. If I talk about this 10 by 3, simple division, we all know how to divide 3 and 10. So here it is 10 and 3. How many times? 3 times. Will occur 9 here, remain with 1, point, again 0, 3, sorry, it's 9 here, okay. So 9, again 1, 0, 3, again 9, again 1, 0, 3. Now, is it going to stop? This is a loop which is continuous. You will be continue getting remainder as 1, 1, 1, 1, 1, okay, and you will be picking 0, 0, 0, 0 and getting this as 0.33333. So I can put these dots. This is one kind. Now the second one is 7 by 8. 7 here, 8 here. Getting nothing. 0.0. Okay, what I am getting now? 6. 0 again, sorry, it will be 0 again here, okay, 7 times 4, 0 again, sorted, getting some zeros here, 1 by 7, come here, this side, 1 here, 7 here, I will be getting point here, 1 times 7, remaining 3, okay. Now I will be getting 0 here, then 4 times 28, 2, 0, I am getting 6 here, 0, 56, 4, 0, 5 times 35, 5, again 0, sorry, 7 times 49, be getting 1, okay, be getting 1 here, 50 minus 49, we will getting 1 here, then again 0, 1, this time 7, 3, be repeating it anyway, okay. This is the third thing, right. So, we have just covered that these fractions in decimal points. So, can I say that I can write this in a rational form? I can write this in a rational form. I can write this also in a rational form. And when we are having, come this side, when we are having such kind of repetition, likewise in that thing, 3.33333, we just don't write it like 3.333 and dot dot dot. We write it like 3.3 bar. What we call it? Bar. We put bar on the particular number which is repeating. Okay. Likewise, here, okay, the complete one is repeating. So, we will be having a bar on this because this complete number is repeating and repeating again. In some case, if you are having 2.323, 13131 and so on. So, if 3131 is the one which is repeating, then you will write it like this 2.32, 31 and 31 bar, right. So, 31 bar only, you do not have to put the bar on the 32, 31, or you will be only having bar on 3 and 1 because 31 is the one which is repeating, not 32 but 31, okay. So, this is the solution for these three. So, just note them and we will move forward. Next question. Noted? Okay. Now, I have talked about the value of root 2, value of root 2 in our graphical representation. Now, value of root 2 is this. Okay. Now, do you see anything like repeating itself? No. Then you are having value of pi is this. Now, mention this that we actually write pi equals to 22/7 in some calculation. In some calculation we write pi equals to 3.14. So, you will say that ma'am, this is the format of P by Q. So, what we will mention is this, that this particular thing is a rational number. No, but it is not, because this is not the exact value, but the approx value of pi. So, we took pi as 22/7 or 3.14. Exactly the value is not like 3.14, because after that we are having so many digits and the digits are not having any repeating pattern. Okay, the pattern is changing and changing and changing. So, we are not having any terminating decimal values here. I have told you about this term, terminating and non-terminating. Here it is non-terminating, but also not repeating or not reoccurring, not repeating or not reoccurring. So, these kind of values are the ones which we are waiting for. and that is non-terminating and non-repeating, and sometimes it is called as non-recurring. That means the value does not reoccur, reoccur, does not reoccur. So, this is the kind non-terminating and non-repeating or non-recurring values, both qualities are here in this particular one, okay. Note this, okay. So, these are the non-terminating and non-repeating or non-recurring ones, which will mention as irrational numbers. These are irrational numbers. So, when I talked about these three examples, like 1 by 7 was one of them, okay, and one was 10 by 3, I guess. So, those three were the example of rational number, not irrational number, because whether if they are repeating, whether they are non-terminating, still they are non-terminating plus reoccurring. But this one is non-terminating, non-recurring. We are getting two non, then we will go for the irrational. Okay. Other than that, if it is terminating, that will be rational. If it is non-terminating plus repeating, that will be rational for sure. But if it is non-terminating and non-repeating or non-recurring, then that will be always this kind of irrational numbers. Okay. Sorted. So, now you will be having some questions on show that this particular number is irrational or show that this particular number is rational. So, you have to deal with such kind of questions that show that particular number is rational or irrational. So, you have to deal with such kind of question, but in our next chapter. For now, just study all that and be with me again in the next lecture. Take care, bye bye.